Hello everybody. Now in this lecture we are going to focus on separation based on the gravity. Okay, first is the centrifugation. First is the centrifugation. So it is an advanced version of settling under the force of gravity. What happens in the normal situation if the particle size is large enough, then the solid or solute easily gets settled down in the form of a solid at the bottom of solution. Okay, but if particle size is very small, under that case is what happens, it not easily gets settled down. So to separate that solids, it is necessary to apply a kind of force, and that force is a centrifugal force which we can apply, and hence the technique is a centrifugation. Okay, and it increases the separation speed. So what happens in this case, we are going to rotate, we are going to fill that solution in a tube or in a flask, and that flask which we are going to now rotate with a very high speed. What happens due to that see, if we rotate that flask, very high amount of centrifugal force will generate upon that solutes. Okay, and that may be revolve, instruments are there where we can maintain the temperature from -4 to -20 degrees Celsius, or -20 to -4 degrees Celsius. The rotations can be provided up to 60,000 revolution per minute. So this technique is very useful for the separation of colloidal system, and it is also used in the separation of biological sample. Okay, so this is a very common technique, and the centrifugal is this type of centrifugal is also available in our biological research lab. Whenever you comes to the college, you just visit our biology lab. Okay, that is also there in chemist lab, but the speed about 6,000 to 7,000 revolution per minute, that can be possible to provide, and even the temperature can be reduced up to -20 degrees Celsius. Such an instrument is available in our research lab. Okay, so this is very important technique. After that, we can see the separation based on the volatility. So a liquid boils only when its vapor pressure become equal to the external pressure. So what we call boiling point of any liquid is the temperature at which vapor pressure of that liquid will become equal to the atmospheric pressure. Okay, that is called as a boiling point. So if we reduce the pressure, definitely the boiling point of any solution can be reduced. Okay, how we can reduce the pressure? If we apply the vacuum, if we apply the vacuum to any solution, or sorry, a liquid, okay, you can say even solution too. So that vapor pressure will get decreased, and under that situation, now I can say you, if I can ask you, is it possible to do the vaporization of water at 0 degrees Celsius? The student may say no, but it is possible if you apply the sufficient amount of vacuum to that flask in which water is kept. Over there, water can be possible to boil even at the 0 degrees Celsius. Okay, so this is what we can do over there. So we can do the normal distillation process if the two liquid present together and they have their boiling point difference about 30 degrees Celsius. If the boiling point difference is less than that, in that case, we are going to use the fractional distillation. Some of the liquids are having very a high boiling point. In that case, we uses the vacuum distillation technique. We apply the vacuum to the flask, and then we start the boiling of that liquid. Okay, then steam distillation technique is also used for the solution or the liquid which are having very high boiling points. Okay, and they are immiscible with the water. But what happens, sometimes there may be the formation of azeotropic mixture. In that case, it is not possible to separate the component easily. Okay, so that is also the question over there, but let it be. All these are the separation techniques which are frequently used in our day-to-day life and industries. Okay, so it's a very common thing to us. Okay, so this is what the thing over here. After this, we are going to learn the solvent extraction. Okay, solvent extraction. So in the solvent extraction, what happens? I would like to tell you that if any substance is present in the aqueous phase, so to take out or to separate that substance or organic substance from aqueous phase or from water to the organic phase, okay, so the technique used is called a solvent extraction technique. It's called solvent extraction technique. Again, I am repeating, the separation of any organic substance from the aqueous phase to the organic phase is called as a solvent extraction process. Okay, this is what we can say all to this slide. Okay, so further in the further slide, the concept will be get more and more clear to you. But remember, solvent extraction technique is a very common practice in the industries as like a crystallization process. Okay, if you go to the R&D, research and development center after your completion of master degree, so whenever you start any chemical reaction, the solvent extraction is a very basic technique which you are going to use over there for the separation purpose. Okay, so it's now very important for you to understand this technique in a proper way, and especially those who are interested to do their career in the chemistry. Okay, and this technique, solvent extraction technique, we are also using in organic chemistry in the organic chemistry practice. Okay, so solvent extraction works on the basis of Nernst distribution law. Solvent extraction process works on the basis of Nernst distribution law. So I just give you, I just stop here on the introductory part. So from in the next lecture, I will continue with the next Nernst distribution law, so that the concept will be more clearer to you. Okay. So thank you.